Hello all. In this video, we learn about the instruction sets of 8086 microprocessor. So the instruction set of 8086 microprocessor consists of so many instructions. An instruction is nothing but a code or a binary pattern which is usually designed in a microprocessor to perform a specific task. It is like programming in the 8086 microprocessor. So we will be writing the instructions or the codes and based on which we will be getting the output. The entire group of instructions that a microprocessor supports is called as the instruction set. And the 8086 microprocessor, it will be having around 20,000 instructions. So we have several types of instruction sets with 8086 microprocessor. So the very first one that we are going to learn in this class is the arithmetic instructions and the logical instructions. So the other type of instruction sets are data transfer instructions, branch and loop instructions, MC or microcontroller control instructions, flag manipulator instructions, shift and rotate instructions, and the string instructions. So the very first one is arithmetic and logical instructions. So the very first instruction that we learn is ADD. So this will be effected with the zero flag, so with the auxiliary flag, with the parity flag, with the overflow flag, with the carry flag. So this ADD instruction is mainly used to add byte to byte or a word to word data. So we have three instructions mentioned here. One is ADD AL, comma 74H. Next one is ADD DX, comma AX. Third one is ADD add AX, comma BX. So the very first one is AL, comma 74H. So where the 74 is nothing but the data will be added with the accumulator lower register. So that is the main meaning. ADD DX, comma AX is we will be adding the data in the AX with the data AX. AX is nothing but the accumulator. So the data in the accumulator will be added with the DX, data in the DX. So the next one is ADD AX, comma BX. So the data or the content in the BX will be added with the content in the accumulator or the AX. So these are the main work of these three instructions. So the next instruction is ADC, DES, SRC. It adds two operands. So two operands are added here. So this also affects the flags like zero flag, the sign flag, the parity flag, the overflow flag, the carry flag, and the auxiliary carry flag. So the same instructions are there here also. So this instruction is nothing but the subtract instruction. So where SUB AL, comma 74H. 74 is the data is given directly and the data is added with the data in the accumulator AL, which is nothing but the accumulator. So sub DX, comma AX means the data or the content in the register AX will be subtracted with the data in the DX. So that is the main work of this second instruction. So the third instruction is we are subtracting the data with the register BX and the accumulator AX. So that is the third instruction. So next one is SBB. So it subtracts two operands and the previous one was like was a basic instruction, but this one is with borrow. Basic one, previous one was a basic one, this one is with borrow. So next one is a multiply instruction. It is an unsigned multiplication instruction. It multiplies two bytes to produce a word or two words to produce a double word. So this instructions will be used to multiply datas. So datas in DX and datas in data or content in AX register. So that is the main work of this MUL instruction. IMUL means multiplication instruction. So that is with signed multiplication. So we have next one is a DIV, division instruction. AH is the higher accumulator, AL is the lower accumulator, lower registers in the accumulator, higher registers in the accumulator is nothing but AH. So DX is the data register and AX is the accumulator register, and IDIV is nothing but the signed division. Okay, so CBW is converting the byte to word. CWD is nothing but converting the word to double word. Okay, so these are like multiplying, but different types. So INC is nothing but incrementing or increasing one value by means of one, or here INC AX means the accumulator content. Say for example, if there is a data 74 in the accumulator, then it will be incremented by 1. So that is the main meaning. So the data in the source index register, SI is nothing but the source index register. So that will be incremented by 1. So that is nothing but INC SI. Decrement is also decreasing the content of AX and decreasing the content of SI. So CMP is nothing but complementing. So it's nothing but comparing. Okay, so comparing two data with one another. One data in the AX register and another data in the BX register can be compared and the output can be produced, and that is the main work of this CMP instruction. NEG is nothing but the complement one, which I told you before. It creates two's complement of the given number. If we have 100, then one's complement will be determined for 100, which is nothing but the reverse of 011 is nothing but one's complement, and the data 1 will be added with the 100 with the original number. So that is NEG. That is nothing but complement. Okay, so uh, complement. DAA is nothing but a decimal adjust after addition. So we will decimal, that is nothing but BCD. BCD. It is used to make sure that the result of adding to BCD number is adjusted to be a correct BCD number. Okay. So AAA is nothing but adjust after addition, and adjust after subtraction, adjust after multiplication, and adjust after division. So NOT is nothing but converting zeros to ones and ones to zeros. That is nothing but the complementing work. So this is one of the logical operation. So AND operation is one of the logical operation. OR operation is one of the logical operation which we use in 8086, and the XOR operation. So it performs XOR operation of DES and SR.